All right. So I want to make today as worth your while as possible, right? Let me kind of finish getting set up and then we can launch into it. Somebody have a question? No, you okay? Screen. Oh, that's me. Let me stop this
I
thing.
had a question
Go ahead.
about it's already a question about the work, but it's about the exam. I turned it in like 20 minutes late. I was wondering if like I could still get my 10 points.
10%.
Yeah.
We can take a look at it at the end. Just remind me towards the end of class.
Okay, sure. Okay.
Let me see. I am trying to share my screen. Hopefully this works because I'm doing it totally out of order today. We're going to start here. Optimize for video. All right. So I'm going to give that a moment to warm up. And while that's warming up, I am going to go ahead and log into this bad boy. Allow. It looks good. I can see it so far, so I'm going to assume that it's working. Definitely is a little bit delayed, but that's okay. Yeah, I can see everything. Calculus. Okay. So we're just going to focus on chapter 1 for today. So here, let me just, I'm gonna just kind of hang out here for a moment. Okay. So gentlemen, we are in the home stretch, right? This is it. So my thought process for today. So basically I think we had the dates wrong initially. I know at a few points in time, we were saying that the last day of class was this Wednesday. It's actually next Wednesday. So May the 3rd is the official last day of class. May the 4th, which is National Star Wars Day, and Cinco de Mayo, that Thursday and Friday, that's the reading period. So the school's going to be closed. So you're going to have that time to yourself. And then, so a week from this Sunday, which is going to be May the 7th at 11:11 a.m., your final exam should become available. It'll be available until Friday, May 12th at 11:59 p.m. That Friday, May 12th at 11:59 p.m., that's the hard deadline for all assignments. Let me check on you guys in Zoom one more time. But yeah, that Friday is the hard deadline for all assignments. Okay. So I want to, I kind of want to do things a little bit different today and try to like shift it up just a little bit, right? So since we have 4 meetings remaining. So basically the thought process is each meeting we're going to focus on the chapter, right? Today is chapter 1, Wednesday is chapter 2, next Monday is chapter 3, next Wednesday is chapter 4, and then we're done, right? And so I want to do the best I can to try to maximize extra credit opportunity during these 4 sessions. And so what I've been doing so far for extra credit is basically recovering points for students on past exams. All right. So if you can answer my questions periodically, I'll be like, okay, this question is worth extra credit. If you get it correct, usually I've been giving students like recovering points as extra credit. It's not because I'm not doing an official bonus. So the offset, instead of doing bonus, is just recovering some points from a missed exam. And that's huge. In most of my classes, the exams carry a heavy weight, right? Each exam in most classes is at least 20%. I think you guys might be somewhere along those lines. So yeah, you definitely want to try to get these extra credit Easter eggs whenever they pop up, right? So let's dive into the material and let's see if we can get some extra credit out. All right. So, well, let's just kind of hop into it. So we're focused on chapter 1. We got a lot for chapter 1. I would like something that's comprehensive for chapter 1. Okay, let me see what I can do. Let's go here, manage, and I'm gonna create a temporary assignment, something that has a little bit of everything from chapter 1. Let me go to create an assignment, create a homework. This is chapter 1 review. Okay. Select the media. I want just chapter 1, differentiation. How many can I do? Can I do all the questions? No more than 150. Okay, so I need to knock off like 100. What's the fastest way to go about this? Come on. It's not moving the way I wanted it to. Now it's not even responding to my touch. Come on. There you go. Let me knock off like 10 questions from each section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let's just keep going. 10, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4, 2, 3, 4, 5, 6, 7, 8, 8. Come on, 9, 10, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6. Come on, 6. Come on, 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need like 40 more. 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should not let me do it. I think I need like 38 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let me see. This might work. Cool. 135 is good. Okay, so it's just what this is just a mix of questions from all of chapter 1. Obviously, we're not going to get through all of this today. I'm not even going to assign it. Yeah, it's just for practice for right now. Okay. So I don't want you guys worrying about this. Let's. Okay. How do I preview? I want to preview it. I don't want to assign preview. There it is. Man, this temperature, like I woke up from, I guess it was this morning and my throat is a little sore. I was like, oh, okay. So, all right. So it says the notation, the limit as x approaches 4 of f of x. Let's see, the limit as x approaches 4 of f of x. As x approaches 4, nope, there's no left to right thing. The limit as f of x approaches, nope, the limit as x approaches 4, right? So then D. Okay, let's do this. First, let me check on you guys in Zoom again. Okay, cool. We got a nice intimate house. What I want to do, there are polls. Nope, this one, right? I think that's correct. Okay, so this one I'm just going to go ahead and choose D. So with these questions, we can launch a poll data to kind of make some decisions about extra credit. So let me see, use the graph of F to find the given limits. Let's look at the graph, right? The limit as X approaches 4, right? So if we're looking at this graph, X is 4 is kind of near the letter F, right? So as we approach, as X approaches 4 coming from the left, Y is getting closer to 5. As X approaches 4 from the right, Y is also still approaching 5. So then this limit as X approaches 4 is going to be 5, okay? Let's turn this off. And we want to put a 5 there. Okay. Really quickly, as X approaches -5. So notice coming from the left, Y is approaching 8. Coming from the right, Y is approaching 5. So then because the left-hand limit and the right-hand limit are not the same, we say that the limit does not exist. Okay. All right, let's see what we got next. As X approaches -1 from the right. So -1 from the right. So coming from the right, Y is approaching 5. All right, so as X approaches -1 from the right, our Y value is approaching 5. Okay. Anybody have the result here? The limit as X approaches 4. Can somebody tell me what happens on the left side of 4? What happens on the right side of 4? Okay, so our Y is getting closer to 5 coming from the left. Y is getting closer to -6 coming from the right. So because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. Okay. As X approaches -1, can anybody tell me about what happens as X approaches -1 here? As X gets closer to -1 from the left, what happens? As X gets closer to -1 from the right, what happens? All right. Okay. So it looks like it's approaching the same Y value, which is what, 1. So we're gonna go with A, the Y value is approaching 1, all right? Whoever does the most talking gets the most, does the most learning. So if I'm doing all the talking, that's the only reason I know this stuff is because I talk about it day in and day out. As X approaches 8, right? From the left, it's approaching 0, right is 0. So then this is gonna be 0, should be 0. Let's see. So X approaches 5. All right, at 5, it looks like we have a vertical asymptote. So the limit does not exist. Okay. As X goes off to the far right, Y tends to 0. And again, if anything is not clear, you just have to stop me.
Professor.
Yes.
So like as X approaches like infinity from like both sides, it approaches 0.
So we don't, when it's going to infinity, we're not doing like a left and right. It's either going to go to positive infinity or negative infinity. So as X goes off to positive infinity, the Y value is getting closer and closer to 0 in this case. All right. It's saying negative, as X approaches negative infinity in this case, Y is getting closer to 1 on the left here. That Y value is 1, right? But they only asked about positive infinity.
Okay.
Yeah. Okay, let's keep going. How many questions? We got a good amount of questions, so we can jump around. We got a good amount. Graph the given function and then find the specified limits. What section is this? This is the 1-1. I don't want to spend all the time on 1-1. Let's jump around. So let's go ahead and move on to 1-2 because I think we got a lot of sections to talk about. Okay, this is something from 1-2. So it says the initial substitution X equals A yields 0 over 0. Simplify the function algebraically or use a table or graph to determine the limit. So I think if we, okay, let's take some notes on this one and let's give this one a go. Let me do it like this. It's a little bit better. Mhm. I'm gonna get a screenshot. All right, that looks good. All right, let's copy and delete. I'm gonna hop here. Like I need to incorporate an oral component, but I feel like the only reason I didn't do all that stuff is I feel like this is kind of enough, right? You know, I'm trying to be as light as possible, but I still encourage you guys to like keep pushing and, you know, make some kind of plan to get this stuff done and take some action, you know. Hopefully I didn't go too soft on you guys, but again, this stuff is a beast all by itself, right? Okay, so we're told that, you know, when we plug in 3, we get 0 over 0. So it looks like with this one, this is probably a good idea to try to factor, right? So if we focus just on the numerator, we have this, what, 4x squared plus x minus 39. I think I'm going to use the AC method of factoring. Let me see. 160, so 156. So 156, right? So we're looking for two numbers that multiply to give us 156. And that's basically going to be 2 times 2. And I think it's a negative in there. And then it's 3 times 13. Those look like the factors. Basically, I said the 4 times the 39. And we're going to go until we get to the line that adds up. And let me do this in like purple because this is like off to the. Yes.
Where did you get the 156 from again?
The 4 times the 39, right? If we're trying to factor this guy, first we need to look at the factors of 156, right? So we're going to go until we get to the line that adds up to 1, right? So then we could say like what, 1 and 156, well, that's no good. We can do 2. If we do 2, this is gone. 6 times 13 is 60 plus 18 is 78. So that adds up to 78. Let's keep going. We can do 3. Notice I'm just on the left, I'm just going 1, 2, 3. If we use this 3, 4 times 13 is 40 plus 12 is 52. So there's a 52 left over. We can do 4. If we use this 4, 39, right? 39 is left over. There's no 5, but we can do 6. All right. 6 comes from these two. So then we got 26 left over. We're almost there. 26. There's no 7. There's no 8. There's no 9, 10, 11, 12. We can do 12, right? And I think those are the two numbers. We got negative 12 and 13. Notice they add up to 1. So these are the two numbers that we were looking for. These two right here. The rest of these were just part of the journey, right? So then next, I'm going to use the box method of factoring. So I like to go something like this. In the upper left-hand corner, I'm going to put the leading term, which is 4x squared. The bottom right-hand corner, I'm going to put the negative 39. And then on the off diagonal, I'm going to use the two numbers that I just found to rewrite this guy. So I'm going to rewrite this x in the middle using the 12 and the 13. So I'm just going to put my negative 12x here and my positive 13x here, right? So now to go to factor this, if we focus on the 2 on the top, what's the greatest common factor? It looks like it's what? 4x. So I guess I'll do orange. We can factor out a 4x from those two. The 2 on the bottom, it looks like we could factor out the 13. The 2 on the left, it looks like we could factor out x is the greatest common factor. And the 2 on the right, what's that, 3 times 13? So it looks like we can factor out a negative 3. Okay. So then long story short, our claim is that that numerator, let me copy and paste, factors into x minus 3 times 4x plus 13. Right? Okay, so now that we have that numerator factor, So the original transforms into the limit as x approaches 3. The numerator we said was x minus 3 times 4x plus 13. I think the bottom is also x minus 3. Okay, so we have x squared minus 9 factors into x minus 3 times x plus 3. Set of 3. Okay. So then we get a cancellation going on. This factor is canceled by this one. So now I think at this stage we can just plug in 3, because if we try to plug in 3 originally, it was given us 0 over 0. Now that we simplify, now I think we can just plug in 3 to get the limit. 12 plus 13, 25 over 6. So that should be the result. I'm just gonna go with 25 over 6. Okay, so that was really a factoring problem and then application of a concept that we talked about. We got 25 over 6. Okay. All right, but that's why we do this review and stuff like this, so we can try to like dust off cobwebs and just try to get through as many of these concepts together as we can. Let's take a few more minutes on this section. The initial substitution yields 0 over 0. If we can't just plug in 4. And we multiply by 1 in the form. I think we can multiply by the conjugate. Will that get it done for us? That'll get rid of it there. I think we can multiply by the square root of x plus 2. We multiply by 1 in the form of root x plus 2 over root x plus 2. That's going to get rid of the radical in the numerator, and it might transform it into a form. That's what I'm tempted to do. It should transform it into a form where we can, let me think about it. Something squared minus something squared. So this one, it might, so with the bottom, you can kind of visualize that denominator as difference of squares, right? You can look at it as something squared minus something squared, and you can make it look like the top, right? Okay, so let me get a copy and let's pull it up and talk about it. Oof. All right, let's copy and delete. Because I had one route that I was going to try, but then I wasn't feeling it, so I tried a different route, and then that was feeling a lot better. Okay, it's a little bit trippy though. Okay, all right. So with this one, we can factor the denominator and make it look similar to the top, right? So I'm just going to focus on the rational expression. The numerator I'm going to leave as is. But that x minus 4, we can look at that as difference of squares. We got something squared minus something squared. So then it can be rewritten as a square root of x minus 2 times the square root of x plus 2. Right? And let's just go ahead and put our limit there. And this is the limit as x approaches 4, right? So then in this form, what? This cancels this. Now we can just plug in 4, and it looks like we get 1 over 4. Okay, that one was a little bit trippy. You know, as you work on these exams, you can ask me questions from your exam. Like, if you were working on it during the time when we meet, you know, say, hey, I'm stuck on this question. Can we talk about it? You know, we can work on it together. You can take this material and work on it with the tutors. You know, it's okay. We got a result of 1 over 4 here. Let me see. We got 1 over 4. Let's try to get to section 1.3. Let's go into the next section. Okay. It's gonna jump around a little bit. Still 1.2. Still 1.2. Okay, let's try this one. State the average rate of change for the situation. Be sure to indicate units. Chris grew from 138 centimeters tall at 13 to 177 at 18. What are the units there per year? If we're talking about a rate of change, so it's centimeters per year. So this is basically slope, right? Average rate of change, generally speaking, is is a slope. So change in y over change in x. So we could say, hey Siri, what's 177 minus 138? 39.
138 is 39.
39. Over, what is that? 5? 39 over 5? Okay, so I'm gonna put 39 over 5. That's like 7 4/5 centimeters per year. Centimeters per year. So I just did the slope. So y2 minus y1 over x2 minus x1. That's what I did. This is also 1.3. Okay, so we have our function. So we want the average rate of change as x goes from 0 to 9 of this function. This is still the slope, right? y2 minus y1. So when you plug in 9, we get it's basically going to be 18 over 9, which is 2. All right. So I just did y2 minus y1 over x2 minus x1. Let's look at this one. So average rate of change is x changes from 2 to 4. Give me my right back. So when we plug in 4, it looks like we get what, 21? When we plug in 2, we get 15. So 21 over 15, 7 over 5. Okay, let's try that again. 24, 21, 12. Okay, 12 minus 3 is what, 9. 21 over 9, 7 over 3. 7 over 3. Damn it, why am I getting this wrong? Let me see. 24 minus 3 is 21. 12 minus 3 is 9. 21 over 9, 7 over 3. 6 times 2 is 12. That's a 9. 7 over 3. I don't understand.
Would it be 7 over 2?
Because we had what, 21 over 9, right? Six times 2 is 12, minus 3 is a 9. 7 divided by 3, 21 divided by 3 is what, 7? 9 divided by 3 is 3, right? Yeah. We got to make some change. Here, let me do this. Do this. And we could even take it a step further. Let's reload and refresh. So what I'm going to do is go to my y equals and put in 6x minus 3, right?
Oh yeah,
And-
Professor.
Uh-huh.
From what I did, I got a 6 for the final answer.
6. Let me try. Let's see. 6x, 6 times 4 is 24. That's a 21. 6 times 2 is 12. Oh, I'm forgetting to do my 4 minus 2. That's what it is. Yeah, I think I was dividing. I don't know what I was dividing by. Yeah, I was definitely doing it wrong, right? But that's probably because I was trying to do it in my head, right? So when we plug in 4, we get what? 21. And then when we plug in 2, we get 9. So it's 21 minus 9 over 2. 21 minus 9 is what? 12 over 2 is indeed. Yeah, 6 is correct. So moral of the story, write this stuff out, right? Don't do the stuff in your head, because that's what happens. You do it in your head, you mix stuff up, right? Okay. Let's keep going. That was good. All right, Mr. Lowe, duly noted. Touche, Mr. Lowe. Okay, Mr. Lowe. Mr. Lowe, the man of the note. Okay, find the average rate of change. Can you give me the result here for this one? All right. Like, can you, the same way you did with the previous, can you give me the result here? Or anybody, it doesn't have to be Mr. Lowe, just can somebody give me the result here? And while you guys work there, I'm going to work here. All right, so we can put, can you get the answer before me? I can make note of that. Okay, all I did was put in my f of x into my y equals. Then all I'm going to do is going to go put the parentheses. I'm going to call on that function. I want to evaluate that function when x is 3 minus, I want to evaluate that function when x is 1. And then I want to say that answer divided by 2. Points are off the board. Maybe we can put a decimal. Let's just put 9 over 4. Hey, let's try another one. So if you can get the answers correct before I do, I can make note of that. Find the simplified form of the difference quotient and complete the following table. We'll do one difference quotient. Okay, I'm going to step away for just a moment. If you can give me the correct answer before I submit it, I can make note of that, right? Difference quotient, so first you want to do f of x plus h, then you want to say minus f of x divided by h. And so if you can give me that simplified difference quotient. So remember, when we first introduced derivative, we were doing difference quotient. You could find a derivative without the difference quotient, but you know, the derivative comes from our discussion on the difference quotient. I'll be right back. Okay, let me take a moment to write this one out. So we're basically doing a difference quotient of negative 4x squared. Negative 4x squared. Fine. So I'll say, find, did you die on me? There it is. Find the difference quotient, right? Negative 4x squared. Okay. Difference quotient is what? F of x plus h minus f of x all over h, right? So if we find f of x plus h first, x plus h squared, x squared plus 2xh plus h squared, negative 4x squared minus 8xh minus 8h squared, okay? So then, next we can do f of x plus h minus f of x. So that's gonna be that negative 4x squared minus 8xh minus 8h squared minus f of x. So double negative becomes positive, so it's gonna be plus 4x squared. Notice we have this guy is canceled by this, right? Then finally, we want to say f of x plus h minus f of x all over h. So that result we got,
So
yes,
where'd you get the negative 8 of 8h squared?
I distributed this negative 4 here, negative 4, negative 4. Oh, it's supposed to be a negative 4h. Let's see. Point goes to Mr. Lowe yet again. 4 times 2, right? So right here. That's what's 4. Same thing here. This is a 4. Okay. Okay. So then we get this negative 8xh minus 4h squared all over h. We can factor out an h from every term on top. We're going to be left with negative 8x minus 4h all over h, and the h's cancel. So then the simplified difference quotient ends up being negative 8x minus 4h. Okay. Ouch. All right. My negative 8x minus 4h. Right here. Negative 8x minus 4h. Okay. Right. There should be more here. Fill in the table. I don't really want to do that. H is 2. Okay, it's not too bad. So what is that? A negative 24. I just don't feel like doing it. I'm gonna go here, go to my y equals, and let me see. X is 3 across the board. That's a negative 24. So I'm gonna say negative 24 minus 4x. And then I'm just gonna call on the function. So for instance, when h is 2, I think we get a negative 32. When h is what? 1, negative 28. When h is 0.1, negative 24.4. And then when h is 0.1. $24.04. Okay. So, the only thing that was changing was h. So I made h my variable, and I put in all the other static components, and then, kept making those changes. Right? Okay. Let me see the time. Okay. So let's get to the next section. Let's get something from 1.4. Let's keep going. Okay, let's look at this one. Find an equation of a line tangent to the graph of this at this point. Okay, this is a good one. If we want the equation of the tangent of the line tangent to the graph at a point, that means what? We use the derivative. The derivative is going to give us the slope of the tangent line at that point, and then we're going to have a slope and a point. So we use those two pieces of information to get the equation of the line. All right. Let's start by getting a copy. Let's see what's going on here. Wow. Oh, I thought they were teaching how to do that. Sorry, I got distracted. Let's get back over here. Okay. Here. Get rid of some of this and a bunch of this. Okay, let's copy and delete. All right. Cool. Find the equation of the line tangent to the graph, okay? Anybody feel like they can walk me through this? Find the equation, or in other words, can you walk me through finding the derivative of this guy? Tell me about f prime. That's what we've been doing all semester.
Uh,
That's going to give us our slope. Go ahead.
when f prime be wait,
So tell me about what's the derivative of 4? The derivative of a constant is
oh, 0.
0, right? Tell me about the derivative of negative 6x squared. What happens with the 2?
It comes over
Okay, and then what does that give us?
negative 12x.
That's it, right? So the derivative of this guy is just going to be negative 12x, right? Okay. We have our x value, so we can plug that in to find the slope. So then f prime of what? 5? It's going to be what? Negative 12 times 5 is what? Negative 60. Okay. So again, that's our slope. So we have a slope and we have a point, right? So do you have a way that, given a slope and a point, how can we find the equation of the line? There's a couple of ways we can go about it. So one way we could do is we can do y equals mx plus b here, right? Let's plug in what we have. So our slope is 60. Our x is 5. We don't know the y-intercept. And our y is a negative 146. Okay. What is that? A 30, negative 300. So add 154. Hey Siri, what's 300 minus 146?
300 minus 146 is 154.
All right, so we got our y-intercept. So now we got our y-intercept, we got our slope. So then the equation of our tangent line should be negative 60x plus 154. Okay. Okay. Negative 60x plus 154. Right here. Negative 60x plus 154. Let's see. Okay. Let's do one more from this section. So it says, list the points in the graph at which the function is not differentiable. So in order for a function to be differentiable, it has to be continuous with no sharp corners or edges, right? So at what points here will this not be differentiable? Where is it not continuous and where does it have a sharp corner or edge?
X sub 3.
Okay, x sub 3 is one of them. What else?
X sub 1.
Okay. Any others? So I think we said it's not differentiable if there's a hole or a gap or if there's a sharp corner. So we got the asymptote, we got a sharp corner. Are there any holes or gaps?
X sub 2.
I think x2 and x4, right? Let's see what happens. Yeah, I'm thinking those. All right, let's go with that and see what happens. All right. So, in order to be differentiable, you have to be continuous and a smooth curve, right? No sharp corner edges. So x2 and x4 had holes or gaps. The limit exists, but it's a discontinuity, right? It's a gap. Okay. let's hang up for like about another 10 minutes. Let's hop to the next section, 1.5. Okay. Mr. Lowe, can you tell me the derivative of this guy? You just did it like a moment ago. Or anybody, it doesn't have to be Mr. Lowe.
Uh, 5x to the 4th power.
Of x to the 4th power. Okay, let's go into the next one. What about this one? What's the derivative of a constant? So can you tell me the derivative of a constant?
0.
Okay. So I think we had just done that one a moment ago as well. What about this one? So what's the procedure? What do we do with the power? First, the power does what?
It's a negative, so we have to
We're doing derivative, right? How do we take the derivative of power in general? The exponent.
we subtracted by 1.
But before we do that, the power does what?
Oh, we bring it down.
Yeah.
It becomes a
So yeah, so the power comes down, we get -7, and then I heard subtract 1 from it. So -7 minus 1 gives us what?
a -8.
-8. All right. So generally the derivative of a power function, the power comes down, we subtract 1 from the power. The only time that doesn't work is if we have x to the power of -1. The derivative of x to the -1, sorry, right? No. So I'm thinking about the integral. So yeah. Yeah, in general, the derivative of the power comes down, we subtract 1 from the power. Now the derivative of natural log is x to the -1, right? I think it's with integration where we have to watch out for that x to the power of -1, because the integral of x to the -1, that one is the natural log. All right, so that'll come up in chapter 4. Can you tell me this? You should be able to just look at it and get it kind of quick. Right? It's the same kind of procedure over and over. Can you tell me the result on this guy?
It'll be 9x to the 2nd power
Okay.
minus -20 to the x power
So the -20x, okay,
plus 32.
plus 32, right? Okay. All right, that looks good. Okay, let me see the time. What about this one? If we do the same thing, what happens?
We bring down the 0.95.
Mhm.
Subtract the coefficient. I mean the exponent by 1.
Okay, and what does that give us?
A -0.05.
Okay, that looks good. All right, cool. Okay, what's this? 1.5. I think we got 8 sections, so I'm actually gonna go ahead and hop into 1.6, or at least attempt to. Take a few minutes on 1.6. So it's like once you get past the whole difference quotient thing, it kind of lightens up. Like, the difference quotient was just an introduction, but then once we started learning the techniques of differentiation, it got a lot lighter. Use the product rule to find the derivative of the given function. Find the derivative by expanding the first product. Okay, so the product rule, right? When we go to take the derivative of a product, I think we said it was what? Can you tell me that rule? How does that rule go? When we take the derivative of a product, how does that technique go? The first,
The first times the derivative of the second plus the second times the derivative of the first.
right? This is it, right? So it looks like we'll probably be working with answer choice D. So if we said the first times the derivative of the second, can you tell me about the derivative of the second?
That'd be 3z to the second power minus 3.
Okay. Okay. Okay, and then so if that's the first times the derivative of the second plus the second, can you tell me about the derivative of the first?
It's negative 2 z.
Yep, that's it, right? Because the derivative of a constant is 0. The 2 comes down, we subtract 1, and that's all that's left. Let's go with it. Progress, right? At least I got through at least one student knowingly, right? I know other people just doing their own thing. I don't know what they are or are not doing. Hopefully this is serving them, because I know this is a challenge and, things are what they are. Expand the product. I don't feel like doing that. Yeah, I really don't feel like doing it. Okay, I'm gonna just take some notes here. Stop being lazy. Right here. Come on. Don't make an obstacle for me, because then I'm gonna use it as an excuse to not do anything. Why aren't you working? I don't get it. Because I keep closing this out. Okay, I think what it is because I'm clicking over there. Okay. See, okay. So then if I just do it without combining like terms, the first term we're gonna get is what? 4z to the power of 3. And then I'm going to say minus z to the power of 5. Okay. And then minus 12 is like z. And then plus 3z to the power of 3 plus 3z to the power of 3. And then plus 4 minus z squared. So plus 4 minus z squared. Let's see if we can find our error. Simplify. Do we have any like terms? I don't think so. 4z cubed. We add the exponents, right? Yeah. Minus z to the 5. Minus 12. Oh, I think it should be a plus in there. Plus 3z, yeah, we got it. Minus 12z plus 3z to the power of 3 plus 4. Simplify your answer. Do we have any like terms? What?
Yeah.
What? The z square. Okay, the z cubed. So 4 and 3 gives us what? 7.
Yes.
That's the one. Okay, 7z cubed. See, now I can't see. Let me zoom out. Okay, that's supposed to be a 7z. 7z cubed. So we can get rid of this guy over here. Okay, that was 1/6. Use either approach. Having like terms. Oh, the derivative, right? So this one to me, it looks like it'll be easier with an expanded form, because the other one we'd have to double FOIL and distribute and combine like terms. That expanded product looks like it's a lot easier to take the derivative, right? So what is that? 7 times 3 is 21 z squared minus 5z to the 4 minus 12 minus 2z. I think that's it, all right? I think the expanded product look, it was more simple to use. Let's hop to section. Did we finish this one? Yeah, let's hop to section 1.7. Okay. So find dy by du, du by dx, and dy by dx. Okay. So the derivative of y with respect to u, so you just take the derivative like normal. The 55 comes down, u to the power of what? 54. So that's the derivative of y with respect to u. The derivative of u with respect to x, so we just take that derivative. 5 times 3 is what? 15 x squared plus 6x. Okay. So then when we go to find dy by dx, we could just multiply those results. But we need to do our substitution for u. That's kind of a lot, right? But we just say that first result times the second, and we need to substitute u in terms of x, right? So it's going to be 55, but instead of typing u, we're going to put 5x to the power of 3 plus 3x squared. Okay, that's u. And then that's all to the power of 54. Obviously, we're not going to expand that. And then we need to say times is 15x squared plus 6x. Okay, that should be it. And that was an interesting one. I'm glad we had this time. Let's do one more and we'll call it a day. Find an equation for the tangent line to the graph at this point, right? So basically take the derivative. We did one like this before. Okay, I guess this is a good one to close out on. Let me zoom in some. And let's take a screenshot of this. I low-key miss my Jellycone keyboard. I just not purchasing it out of spite. The keyboard was falling apart. And so I called them and they were like, well, when did you buy it? I called them on like March 10th or something like that. And I had bought it March 4th, a year ago. So it had gone past the warranty by like a couple of days and they wouldn't honor it. I was like, you know what? I'm gonna just get a different keyboard. It's like, he could have honored that warranty, but you know, they like to be by the book when it comes to us. So I was like, you know what? I'm good. So needless to say, I did not get another one. It was a decent keyboard. It took a little bit to get used to, but there's a different one that I want to get. It's like one that like you wear on your hand and you can like type through gestures. I was gonna try it out. It looked like fun, but it's kind of expensive. Also, I was getting it for the Oculus. All right, I was thinking about getting like an Oculus 2 or whatever. We'll see. Just because, for no reason. Okay, find an equation of a tangent line, right? So first, let's find the derivative. So then let's just find dy by dx. Yes, I know. Thank you. Stop. I missed. Okay. So dy by dx. Let's see. The 14 comes down. The x cubed minus 9x persists. That now becomes a 13. But then we need to say times what? 3x squared minus 9. Right? Okay. So then we want to evaluate this when x equals -3. So then it's going to be a lot. I'm probably going to use my calculator. To the power. Add an extra parentheses in there. So the 13. 3 times -3 squared minus 9. Yeah, let me just use a calculator. So now we got what? 14 parentheses x to the power of 3 minus 9x quantity to the power of 13. Then we want to say all of that times 3x squared minus 9, okay? So then we want to evaluate this function when x is what, -3, and we get 0. Muy interesante. Let me see, is there a 0 there? Right there, right? That's -27, that's a +27, so that does collapse everything to 0, so it's a flat horizontal line. So I think it's just going to be y equals whatever the y value is. We have the slope is 0. Here, let me do this real quick. I don't know why I'm kind of like being stuck on stupid. Come on, there we go. Oh, come on. Okay. So we got a slope of 0, right? And we also have this point -3, 0. So then if I were to use like y equals mx plus b, so then it's just going to be y equals b because the slope is 0. So then when x is -3, so b is 0. So then it looks like it's just y equals 0. Yeah, just y equals 0. Let's go with y equals 0. Nope, here. Okay. All right. So that was a review of chapter 1, right? So we went through as many sections as we could. We got through about 7 sections, at least touching on each section. Mr. Lowe, I'm going to honor your request that you made at the beginning of class because you were engaged, right? So I'll honor that I'll just remove the late penalty for that exam. I guess your exam too. Are there any other burning questions before we go our separate ways?
Well, I just have one question on one of the homework sections.
Okay, go ahead. Go ahead and did you email it? Like, just send an email again if you can.
Okay.
Let me. I don't want to stop the stream just yet. Remind me when I finish this question to update your grade. This dog is hilarious. She just wants all the attention. She's so spoiled. She thinks she's the queen of the castle. She thinks she owns everything. And she don't have nobody to play with but like me and whoever else is around. She's so silly. Nope. You got to give me a few minutes. No. Nope. Yeah, you got. No, stop. No.
Yeah, I just sent it.
Let's see. So this comes from 4.4, question 32. It says, find the area of the region bounded by the graphs of the given equations. So you have 2 parabola. Okay. All right, let me get a screenshot. Copy and delete. Let's paste. I just need just a vitamin boost, really. The temperature changed. Like, I guess I was like being too comfortable outside and the temperature just dropped and it kind of snuck up on me a little bit, just a little bit. It's not anything bad or unmanageable, but I want to nip it in the bud before it gets worse. Find the area of the region bound by the graphs of the given equations, all right? Okay, so first let's find where these two graphs cross each other. We have two U-shaped curves. And let's see at what values of X do they cross each other. So what we're gonna do, we're gonna set them equal to each other. So we have this 2x squared minus 5x plus 10. We want to set that equal to x squared plus 7x minus 10, right? So then we can set it to 0, so move everything to the left. If we subtract x squared, we're going to get x squared. If we subtract 7, we're going to get negative 12x. If we add 10, that's going to become 20 equals 0. Can we factor this into this form? X and x, minus and minus, 5 and 4, 6, 5, 10 and 2, 10 and 2, right? So two numbers that multiply to give us 20 and add to give us 12. Negative 10 times negative 2 is positive 20. Negative 10 plus negative 2 is negative 12. So then the x values here, well, they're 2 and 10, right? So they cross when x is 2. So we're going to integrate this as x goes from 2 to 10. But then we also need to figure out which function is on top of the other, right? So I'm just going to choose an x as halfway, right? So let me see, what is that? 8, so 4, so 6. When x is 6, I'm just going to plug in x, which is 6. Whichever has the higher y value, I'm going to say that that's the one on top, right? If we plug in 6, I'm gonna use my calculator. I don't feel like crunching numbers right now. So I'm gonna do 2x squared minus 5x plus 10, right? Then I'm also gonna do x squared plus 7x. And I'm pretty sure it's that wider one. The first one is on top, but we need to confirm. Minus 10, okay. So then what I'm gonna do, I'm just gonna evaluate this. I'm going to evaluate both of them when x is 6. That's going to give us an answer. And this other one should give us a smaller y value. It should be below, right? When x is also 6, right? Oh, it's not. Let me see. Oh, that's more narrow, right? Okay, that makes sense. Yeah, that's fine. Right? So it still makes sense. I got a concept mixed up, but we're still good, right? So that means that the second equation is the one that's on top. So when we go to integrate, we need to say the second equation minus the first equation. Okay. So we're basically saying the top equation minus the bottom equation. So then now we're ready to set up our integral. So we're going to find the integral as x goes from 2 to 10 of the second one minus the first one. So we're going to say x squared plus 7x minus 10 minus the first one, which is 2x squared minus 5x plus 10, and then basically dx, right? That's the integral that we're evaluating. Okay, so let's simplify this guy first. The integral as x goes from 2 to 10. If we combine like terms, that's going to be what? Negative x squared plus 12x. Looks like that's a minus 20 dx. So then now we're ready to integrate. That's going to be what? Negative x cubed over 3, x squared over 2. So then 6x squared minus 20x as x goes from 2 to 10. So I think I'm going to just use my calculator for that part. Okay, I'm just going to put this in the third slot. So we get this negative x cubed, x to the power of 3. Hopefully the way I'm typing it in is proper. Plus 6x squared minus 20x, okay?
Last year.
Thank you. All right. So then we want to call on the third function that we just inserted. We want to evaluate it when x is 10. Then we're going to say minus that third function Nope. Go back. The third function evaluated when x is 2. Okay. We get 85.3 bar. And let's see, it says simplify your answer. The area between the curve. I guess I could put the fraction. So I'll do math as a fraction. Let's do 256 over 3. Let's see what happens. So I'm on my phone now. 256 over 3. That is correct. All right. So this answer is correct. And then I just put it in as 256 over 3. It should accept. I did the 256 over 3 because that's going to be exact, right? If the 3 bar, you know, I don't think it has the bar as an option. So if I put 85.3, that's going to be off. So that's why I did the fraction. Okay, are there any questions there? Did you have any others that you wanted to go through?
No, sir.
So let me go ahead and make a copy of this available. Share, I'm gonna send it to Box. That should be good there. When this bar finishes loading, you'll receive a copy of anything that you saw me writing. And I'm gonna log off the live stream, and I'll go ahead and, you know, remove the late penalty for that assignment for you. And if there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. On Wednesday, we'll work on chapter 2. Right. So similar to what we did today with just chapter 2.
So you'll be able to get our points back?
He was able. So I think I made a disclaimer that, like, at the beginning of class, anybody that was like engaged, I wanted to get some points out to people. So, but it was whoever was engaged. He was the only one engaging. So he you know, I can honor that request. What I've been doing for most students is just giving them points for like missed questions on exams. But he was like, "Can I just get the late penalty removed for that one?" I was like, "Okay, that's fine."
Yeah, I had a late penalty. That's what I was talking about.
Is this Mr. Lowe or?
This
No,
is
that was
Ethan.
just extra credit because he was engaged. So
Yeah, I'm
maybe,
not asking for extra credit. No, I'm not asking.
yeah. I'm going to remove this late penalty, but there might be an opportunity similar on like Wednesday, right? So I'm still open to something like that on Wednesday, even and all next week as well. So these opportunities are going to keep popping up if you just kind of like listen, tune in, and oftentimes they're simple questions. I just need like feedback. I need you guys to engage a little. And you can recover like massive points. Like that's huge to recover points on an exam, especially something like this. So if you tune in on Wednesday and even next week, there should be some opportunities as well for something similar.
Okay.
Okay. Yep. All right, guys, let's try to get some more points out next time. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy your evening, guys. Okay, take care. Let me stop the stream. We didn't use that. That's fine.